Numerical Methods Problem 10.25. Polynomial interpolation consists of determining the unique n-1 order polynomial that fits in data points. Such polynomials have the general form f of x equals p1 x to the n-1 plus p2 x to the n-2 to p of n, where the p's are constant coefficients. A straightforward way for computing the coefficients is to generate n linear algebraic equations that we can solve simultaneously for the coefficients. Suppose that we want to determine the coefficients of the fourth order polynomial f of x is equal to p1 x to the fourth plus p2 x to the third plus p3 x squared plus p4 x plus p5. That passes through the following 5 points: 200 at 0.746, 250 at 0.65, 300 at 0.616, 400 at 0.525, and 500 at 457. Each of these pairs can be substituted into equation 10.25 to yield a system of 5 equations with 5 unknowns, the p's. Use the approach to solve for the coefficients. In addition, determine and interpret the condition number. So, given to us by our problem, we have a set of x and y values. So, for our y values, we make our B matrix. Simply set it to the numbers that are all the y values given to you. And for our A matrix, we take the x values given to us and the value of 1, because p of 5 is not multiplied by an x value of any sort, so it's just multiplied by 1. So when we create our A matrix, we use the x's given to us, and then we set them to the power of the equation. So we have our x's set to the fourth, our x's set to third, second, and first, and then just our x's, just as the equation in the problem describes. And then we simply solve for our p's, or our coefficients, by taking a backslash b, and then that'll give us our p's, or our coefficients. And then we check our answer by multiplying our A matrix by p, and then this problem always asks for the condition number, so we do the condition number of our A matrix. So let's run it up. As you can see, here are the values given to us for our B matrix, or our B vector. This would be our values of y given to us by the problem. And here is our A matrix. That was found by using the equation given to us in the problem, setting it in matrix form, and using the coinciding x values to find this matrix. And then here's our solution from A backslash b. So here are our coefficients, and then when we multiplied our matrix by our coefficients, we're back where we want to be at our y values. And then if you take the condition number of the matrix A, we receive 1.1712 e to the 13th. So it's a very large condition number, so this matrix is clearly ill-conditioned. And that's it for problem 10.25.